Hey everyone, and welcome to The Explainer. Today, we are taking a seriously mind-bending journey together. We're actually going to connect an ancient, 2 millennia-old Buddhist dialogue directly to the bleeding edge of modern quantum physics. We're going to deconstruct reality, challenge the very nature of matter, and literally shift how you perceive every single object sitting around you right now. Let's dive in. Our central mystery starts with a pretty incredible story. Picture this. It's around 150 BC, and King Milinda is interrogating an arahant, which is a fully enlightened being, named Venerable Nagasena. When the king flat out asked if time actually exists, Nagasena didn't just give a simple yes or no. Instead, he said that for beings who will be reborn, time exists, but for those who won't, time does not exist. Understandably, this completely baffled the king. I mean, how can time exist for some people, but not for others? Doesn't a fundamental thing like time either exist for everyone or just not at all? So let's figure this out in Section 1, The Illusion of Time. To really grasp Nagasena's riddle, we have to rethink how we usually experience time. For most of us, our common sense is basically operating on Sir Isaac Newton's idea of absolute time. Newton believed time was this incredibly real, tangible thing that just ticks forward consistently, totally independent of anyone perceiving it. We feel like we were here in the past, we're here right now, and we'll be here in the future. But what if time is just a medium? Think about it like this. To learn math in school, you absolutely need language as a medium to transfer that knowledge, right? Well, in the exact same way, time just acts as a medium for change to occur. We say we're boiling pasta for 10 minutes, or we measure aging in years. But under the hood, what's actually happening is just constant, continuous change.
Let's make this more concrete in Section 2, the snake game analogy.
To completely break down how our brains process this illusion of change, let's take a trip down memory lane. Remember those old, indestructible Nokia 3310 phones? The ones with the classic game Snake? When you play that game, what are you actually looking at? Step 1. Your phone screen is literally just a grid of static pixels, individual little squares simply illuminating or staying dark. Step 2. Our minds instantly, almost automatically, group those totally unrelated flashing pixels together. We force a relationship onto them. And then, Step 3. Because of that mental grouping, we suddenly perceive this unified, moving entity that we call the snake. So, I've got to ask you, did that snake actually travel from point A to point B? If you look at the raw physical reality of the device, the pixels themselves never move an inch. One turns off, the one next to it turns on. The arrangement changes, but there is absolutely no thing or entity that travels across the screen. The moving snake is entirely a fabricated illusion of your perception. And keep this in mind, because this is a perfect analogy for how we mistakenly view the movement of particles in our physical reality. Which brings us to Section 3, Understanding Dynamic Equilibrium. If the moving snake is just an illusion created by changing pixels, what are we really looking at when we see a supposedly solid, static object in the real world? The secret lies in a classic classroom concept known as dynamic equilibrium. It's defined as an apparent static state created by the continuous, unchanging net effect of constantly changing causes. I know that's a mouthful, so let's break it down. The object itself isn't static. The underlying causes are constantly shifting and changing, but their net effect gives our brains the illusion of a solid, unchanging thing. This concept is everywhere once you start looking for it. Even when you pull up a supposedly static photo on your incredibly advanced smartphone, that display screen is continuously refreshing, pushing power, rapidly firing pixels thousands of times a second. An unseen hyperactive process is constantly happening to maintain that image. It's exactly like the temperature in your room. The invisible air molecules around you are aggressively moving, vibrating, and colliding right now. But the net effect on your skin just feels like a constant static climate. Our human minds just desperately want to group these rapid, ongoing processes into neat, static units. Now let's scale this up in Section 4, the electron radius paradox. Okay, so this is where things get really wild, because this isn't just some fun, philosophical brain teaser. Taking that pixel analogy and scaling it up is actively breaking modern physics wide open. In quantum physics, scientists make a huge foundational assumption. They treat a particle, like an electron, as a discrete, independent unit, and then they try to map its movement through time. But remember the snake? Just like assuming that digital snake is a real, solid object, physicists are assuming matter is made of these discrete, independent entities, and honestly, it's causing massive mathematical paradoxes. To put that into perspective, consider the famous problem of the electron's radius. If physicists try to model the electron as a point-like particle with zero radius, the math completely breaks down and generates infinite self-energy. It's an impossible paradox. But if they try to fix it by giving the electron a finite radius, it suddenly becomes completely incompatible with Einstein's theory of relativity. There's literally no way to win. No matter how they measure this supposed independent unit, it fundamentally breaks the math. So why are the brightest minds in physics struggling so hard with this? Well, it's because they're starting with the wrong premise. They're trying to measure how an independent entity changes. Actually, scratch that. They are assuming the static entity exists independently in the first place. Asking questions about how a discrete static unit changes over time is like asking for the name of a daughter you don't even have. Whether you say her name is Julie or you say she doesn't have a name, you're answering the wrong question entirely. The whole premise that the daughter exists to begin with is flawed.
Let's find the solution in Section 5, the reality of anicca.
To actually resolve these paradoxes in modern physics, we have to look back to the wisdom of the Buddha, specifically the concept of anicca, or dependent origination. This principle states that any phenomenon is solely the net effect of causes and conditions, period. There are zero isolated, static entities in the universe. If quantum physics simply applied anicca, the whole electron radius problem would just vanish. Why? Because an electron isn't a discrete point-like particle, and it's not a solid sphere either. It's merely a temporary, fleeting arrangement of causes, exactly like the flashing pixels creating an image on your screen.
So here is the absolute crucial takeaway. The names we give things are just temporary labels for how causes happen to be arranged right in this moment. The exact same energy manifesting as a water bottle today could manifest as a pen, a tree, or even a person tomorrow. And this is exactly why the Arahant, Venerable Nagasena, completely baffled the king. Nagasena doesn't perceive time because he doesn't mistakenly group reality into separate solid units. And if you don't have static units, you don't need the medium of time to measure how they change. He just sees a continuous, unified flow of conditions.
Which brings us to our final thought for this explainer. I want you to take a second and literally look at the device you are watching this on. Look at your desk, the walls around you, even your own hands. Are you really surrounded by solid things just sitting statically in the passage of time? Or are you simply witnessing a vibrant, flashing, dynamic equilibrium of conditions? Because I promise you, once you stop seeing the snake and start seeing the underlying process, reality will never look the same again. Thanks so much for joining me on this explainer, and always keep questioning what you see.